right, so we're going to prove by the principle of mathematical induction that n+1 factorial is bigger than 2 to the n+3 for all n bigger than or equal to 5. Okay, so let's go ahead and start this proof by PMI. All right, so we're going to do our base step. We're going to consider the statement involving 5, right? So that is 5 plus 1 factorial has to be bigger than 2 to the 5 plus 3, which is the same thing as 6 factorial, which is 720, has to be bigger than 2 to the 8th, which is 256. So that definitely checks, right? All right, so now we're going to move on to the induction step. So we're going to suppose the statement involving some k is true for some k contained in the natural numbers where k is bigger than or equal to 5. All right, so this implies that k plus 1 factorial is bigger than 2 to the k plus 3. All right, so remember we want to prove that it is true for the next term in the sequence, which would be k plus 1, right? So let's go ahead and consider k plus 1, right, plus 1 factorial. Right, where the k is, we're going to plug in k plus 1. Now, this is equal to k plus 2 factorial, right? And remember, we want to show that k plus 1 factorial is bigger than 2 to the k plus 1 plus 3, right? So eventually we want to get down to, we'll have 2 to the k plus 1 plus 3 down here. And we're going to try to connect these two, right? Let me actually scoot it a little more. Okay. So we know k plus 2 factorial is the same thing as k plus 2 times k plus 1 factorial. And from our induction step, we know that k plus 1 factorial is bigger than 2 to the k plus 3. All right, so we know this is bigger than k plus 2 times 2 to the k plus 3. Right? So how are we going to connect these two, right? Well, let's go ahead and move this down. I think we might need a little bit more space. Okay. So we know that this is equal to 2 to the k plus 4, right? And this is equal to 2 times 2 to the k plus 3. See how I needed that 2 to the k plus 3 here? And now I have this k plus 2 where the 2 is. But hopefully that you can see for k bigger than or equal to 5, we know that k plus 2 is bigger than 2, right? So as you can see, we have this k plus 2 here, and we know this is going to be bigger than 2 times 2 to the k plus 3, right? Because for k greater than or equal to 5, k plus 2 is bigger than 2, right? Because 5 plus 2 is 7, and that's bigger than 2, right? So any k bigger than 5, we know that k plus 2 is bigger than 2, right? So as you can see, we're able to get k plus 1 factorial is bigger than 2 to the k plus 1 plus 3. So this implies, right, that k plus 1 plus 1 factorial is bigger than 2 to the k plus 1 plus 3. So this implies that s of k plus 1 is true, right? Assuming that the statement involving k was true, right? We're able to get that s of k plus 1 is true. Therefore, by the principle of mathematical induction, for every n contained in the natural numbers, where n is bigger than or equal to 5, s of n is true, right? AKA, we've proven that n plus 1 factorial is bigger than 2 to the n plus 3 2 to the n plus 3 for all n bigger than or equal to 5. And that is our proof.